Hello everyone, I am Arpit Bhatia. Today I am going to present our paper exploring the design space of badge-based input. This is a work by me and my co-authors Yajur Ahuja and Suyash Agarwal under the guidance of Professor Aman Parnami at Weave Lab IIIT Delhi. Clothing has a fundamental role in human culture. Despite this, wearables are traditionally worn on the body. In this paper, we leverage clothing as a layer on the body and explored the idea of input with wearables that can be attached and detached at will from any of our regular clothes. We refer to these wearables as badges to relate them to a common accessory. Smart clothing, such as Project Jacquard and Pinstripe, is one way through which researchers have tried to combine wearables in clothing. However, embedding electronics into clothing faces certain issues: the need to own multiple articles for everyday use, precautions to ensure washability, resistance issues, etc. In this work, we study an alternate way to combine technology in clothing, which aims to counter these drawbacks. Our aim is to study the different ways to attach and detach technology at will from any part of a user's clothing and explore the set of gestures such an affordance can enable. We start with an extensive study of different ways to fasten something onto our clothes. We looked at common fashion accessories such as brooches and lapel pins, commercial wearable devices, existing research from the Ubicomp and HCI communities, and talked to experts such as fabric shop owners and badge manufacturers. Based on the information from these sources, we were able to compile a list of 15 non-permanent clothing fasteners. Having surveyed different kinds of fasteners, we then moved to study the act of wearing a badge and how people envision using a badge as an input device. We conducted a formative study with 12 participants with the aim of gaining insights to build a fastener design space and a gesture vocabulary. We created badges for each of the 15 fasteners and asked the participants to try each one out and fiddle with them in as many ways as possible. They were then asked to act out how they would control GUI elements and consumer electronics using these badges. Lastly, we asked the participants to rate each fastener on a 5-point Likert scale for comfort and their willingness to wear such a badge publicly. A graph summarizing the results of the Likert questionnaire can be seen in this slide, where we observe that magnet, drawstring, lobster clasp, and bar lock are the most preferred fasteners in both categories. Kindly refer to our paper for further details on the study results. Based on the observations on how the participants put on, held, positioned, and manipulated the badges, along with the physical properties of the individual fasteners, we created a design space of badge fasteners with the following dimensions: rotatable, movable, and pullable, which are the physical manipulations a fastener allows without being undone; has a temporary effect, which refers to certain fasteners leaving stains and wrinkles, which can be removed on washing and ironing respectively; needs connector on both sides of clothing are fasteners with sandwich clothing between the two parts that attach to one another. Specific to a part of clothing, as the name suggests, are those which attach to limited parts of clothing, such as the hem or the cuff. Cannot be reattached after removing are disposable fasteners which need to be replaced after every use. Can be used to hide badges underneath clothing are those which, when fastened on the underside of clothing, are able to conceal the badges completely. Combining our knowledge from the fastener study, observations from the formative study, and existing literature, we then created an input space for the badge form factor with 26 gestures. For this work, we are concerned with gestures enabled by 3 entities: the fastener, the badge body, and the wearer's body and clothing. Our set of 26 gestures is classified into 2 categories: touch gestures, which are based on the body of the badge, and physical manipulation gestures based on the fasteners. Please refer to our paper for detailed descriptions, properties, and applications of these gestures. We would also like to state that these 26 gestures are primitives, and the input space can be further expanded by considering repeated performance combining operations bimanual operations, etc. To summarize, there are two primary implications of our work. First, the design space of fasteners can fill in the void regarding non-permanent attachment methods in the community. We hope that it promotes discussion amongst researchers and designers on the possibilities enabled by the affordance of a non-permanent on-clothing wearable. Second, a fastener design space and input space make for quick reference when choosing a fastener and the enabled gestures while creating a new badge-based wearable. For future work, you'd be interested in exploring other interactions such as those between two badges and between badges and non-wearers. Another extension of this work could be to try to think of custom fastener designs that support specific combinations of dimensions. Thank you for your time.